see the full PowerPoint there, Dwight?
Yeah.
Yeah, cool. Just to check it's not the presenter view.
Okay, I'm going to start letting people in early.
Yep.
Got 2 guests joining us. Hello. We're just waiting for at 11 o'clock just so that people can start coming. So it's about 5 minutes before we get started. So obviously we open things up a little bit early just so that people can start joining and coming in. So I'm not sure how to say your name. Is that George?
Giorgio.
Yeah. Where are you
Giorgio,
from?
Sorry, I renamed myself. Sorry, this was for another meeting. I renamed myself immediately.
Good.
And I attend both as an enthusiast of classic vehicles and as an expert in 3D and a journalist of A3DM magazine.
Good. Yeah, I'm hoping for quite a few people to join us. We'll see. But we have made this, just so you're aware, we have made this broadcast across quite a few social media channels. So a recording of the video will be, of this whole meeting, will also be on YouTube and Facebook and all that kind of stuff. We want to try and maximize our reach at this time. Okay, we'll be starting in about a minute or so. As people come in, we'll add. Okay, so Yes, we can start now. So thank you very much for all attending and for wanting to be part of this webinar. Let me just get this up and running. Dear me. Excuse me for 2 minutes. My other computer's just giving a bit of a problem. So the reason for this classic vehicle and preservation using 3D printing services webinar is because obviously with the technological advances that have been made over the last few years, we wanted to just bring you how we can restore classic cars, and how many classic cars are being restored using 3D metal printing, and not only 3D metal printing but also using composite composite printing. So we've teamed up with the next slide, please, Seamus. So we've teamed up, or in conjunction with Mark3D, we've just put this little webinar together, this little hour presentation together with you, just to show not only the usability or the affordability of metal 3D printing, but also the feasibility, which Seamus, I won't go into too much of that. But who are we? The next slide, Seamus. So we are Mitchell & Son 3D Printing Services. We are a little company based down in Southampton with our one goal in mind. Our one goal in mind is to close the space gap market. Why we decided to do that is because we had done a number of surveys into the classic car market, and one of the biggest issues, which I'm sure anyone who does any kind of restoration would know, that the biggest issue with restoring classic cars is finding and locating spares. So that is what we do. We provide a bespoke reverse engineering and CAD service, because that is in creating spare parts. One of the big things is to be able to create a 3D model of that item, and then to reverse engineer that in CAD, and then to reproduce it in a variety of materials. Who am I? I am Dwight Mitchell. I'm the owner of Mitchell & Son 3D Printing Services. I did my apprenticeship starting in 1988 to 1992 as a petrol and diesel mechanic with Coca-Cola in Johannesburg. And I have been working in the last 15 years in support roles in the engineering sector, working for companies like Eaton Aerospace in a support role. I worked for Nokia before they ended up closing their doors, and also recently working for Whatzilla and Haven for the last, say, 6.5 years in a support role. So Mitchell & Son Additive Manufacturing, we registered the company back in 1999. And we officially launched the company probably in April of 2020, right in the middle of a pandemic. Yes, I hear you say that. But it's been interesting, and it's been growing. So I'd hand you over now to Seamus, just to tell us a little bit about who he does. If you want to go on the next slide, who Seamus is and who Markforged is. Seamus.
Yeah, morning everyone. My name's Seamus. I work for Mark3D UK. We're a European group that specialise in and a partner of Markforged, the 3D printing company. I'll come on to a bit more about them later on. We work with customers across Europe since we started in 2016 to install, use and adopt the full range of Markforged printers. My personal background, I've come from the 3D CAD world. Used to teach 3D CAD and work with businesses to adopt 3D design tools, and last year moved over to the additive manufacturing space. Sort of have the best of both worlds, being coming from a design background and now looking at taking those designs into additive manufacturing. And excited to be here today and interesting to sort of think about and talk about this topic.
Okay, so why? Oh dear, I'm on mute. Yeah, I'm on mute. I do apologize. Oh, my soul. Okay, sorry about that. I've just dropped my mouse. So why the whole 3D print? Well, I mean, why this webinar? In the recent years, as we all aware, the automotive industry has been put under a lot of pressure to change what they do, to change the way they do it, and to produce quicker, smarter, more friendly, kinder to the environment solutions to the automotive industry. So 3D printing is been getting very involved in that, and a lot of the automotive manufacturers are taking on board 3D printing in a very big way. A number of those is BMW, which has been, I know BMW actually has been doing 3D printing for their classic car market for almost 30 years. So that's something I've recently found out. I thought that was quite astonishing. But I'm going to hand back over to Seamus at the moment, so that he can then tell us more about Markforged and what they do, and the services and products that they have, and a little bit more about the technology that they have produced over the last few years.
Well, thanks, Dwight. So, yeah, when Dwight reached out to us and asked us to collaborate on this, we've got some case studies which I'm going to share later, which really prove and show what we're doing in this industry at the minute. But he also asked us to just discuss this idea of feasibility of using this technology for classic car restoration. And I just wanted to talk about this for a moment, because I think, as I was thinking about it, there's a big difference between the possibility of a technology being used in an application and actually the feasibility of that being done in an industry for an end user by a business who needs to be profitable. In my personal opinion, we've got to this point over the last few years where it has gone from just possibility and proof in R&D to actually being a feasible thing, and a couple of reasons I think personally we've got that. So the first thing is just to start with a really simple question and answering this question open of firstly, is it possible to do this? And the real simple answer to this is yes, and it really highlights something I wanted to say straight away, is that this isn't a new thing. I'm not here today that suddenly we can print end use parts, and it's been something that's been done for a long time, and I think I'm more here to talk about this move from possibility to feasibility, which we've seen over the last few years. When you look throughout various places on the news, on the internet, you can see examples of where this has been done and this is possible. A lot of the big automotive companies are doing it. And a couple of examples here. BMW restored Elvis Presley's Beamer, which was finished in about 2016, and this was restored using some 3D printed parts that were no longer available. They didn't have the parts there, and the best way to remanufacture them at a low cost, because of the low volume, was to use additive manufacturing. Jaguar, this is the XK120 SE, I believe. It was restored in 2017. Again, heavily relied on 3D scanning and 3D printing to get to this point. So, big vendors, big automotive OEMs, are doing these things and proving that it is possible. A slightly different one, but a VW microbus that was restored in 2019. This was actually converted to electric and 3D printed the mirrors and the wheels. So not quite restoration, because you can see by the image they actually went on to a different design to sort of incorporate the vintage with newer electric, but a similar way, and a very famous one again, the Bentley blower. This was both restored but also they produced or are currently producing 12 new replicas of the original, which again, both the replicas and the original is heavily being relied on 3D printing. So again, it's just to say that it's not a new thing. It's not something that I'm here today to say we can suddenly do. It's been used for a long time. But again, I wanted to next go on and talk about this feasibility of using it, and how can it be used in this industry and by anyone really. And the first thing I want to do is really start to break down a bit of a skepticism, I think, around 3D printing. A hearing that I read a lot and see a lot in my world is it's not just about Yoda heads. And I think this is really stemmed from the amount of replicas or figurines that you see printed all over the internet, in the news, and I think it's fair to say that it's given a wide view that 3D printing is not really ready for creating real functional end-use parts. Although, I think this is a mindset I fully intend to change in today's session when we start talking about applications. And I think one of the reasons for this is, or another view is something like these things, and yes, that is a chicken nugget holder attached onto a car wheel. And, we all may think that's a great idea and dream of doing that while we're driving, but it doesn't necessarily help get across this point of what additive can really achieve. And I think for me, a part of that is that it's a wide scope. It's a huge industry with a huge amount of vendors, a huge amount of technologies, and you get 3D printers that are for hobby use, which are great. You can change a lot about them. You can input all the settings you like and print things, and that's the thing that you really see across lots of social media channels. Whereas then there's this other area of additive manufacturing, which is the industrial use of printers and the industrial technology, which you may not as often see if you're not in the 3D printing space and know where to look for those sorts of news articles. So why has it become more feasible, or why do I think it's become more feasible? And I think there's a lot of different reasons for this, but just two today that I personally want to highlight, and why I think, again, more recently it's become more available and accessible to everyone. And the first point is that 3D printing technology has and continues to become more suitable for manufacturing end-use parts. I'm not an expert in all additive technologies. I work specifically with the Markforged technology, so there'll be applications that I may not be aware of and certainly won't talk about today. But across the board, metal printing is growing and improving rapidly. And we're getting to this point where we can, and a lot of businesses are successfully 3D printing end-use parts. New applications are emerging all the time. Some here just as examples on the left. I can't remember how recently this was, but Porsche have 3D printed successfully and ran pistons in an engine. I believe this was actually for a newer car, but again, no reason why it couldn't be used on a vintage car as well. RPG Industries, this is actually a Markforged customer over in the US. I've got some slides about them later to talk about what they're doing, but they've successfully 3D printed a carburetor, a vintage carburetor on the Markforged Metal X. Again, it was a part. A customer came to RPG Industries with this part. They couldn't get it anywhere in the world. It would have been very cost prohibitive to CNC machine it. And they were looking for an alternative, and they were able to 3D print this. On a different side, or some examples that aren't in classic car industry, but just to go on to another point, that not only are companies and 3D printed technology successfully printing metal end-use parts, we are also getting to the point where we are now seeing certain technologies and processes actually being certified by governing bodies. So a recent thing in the news this year, I believe, or late 2020, was that the first FAA approved part was 3D printed in metal. I can't remember which technology it was using, but it has been printed, approved, and is on a commercial plane. I think it's a part that holds one of the sensors, but again, big step forward from not only, yes, we can do this, but governing bodies are saying, we will use this, and we will approve it for flying. And then on the right hand side there, this is actually a composite part, again, a Markforged customer over in Germany, I believe, Primital, and it's the first CE validated lifting tool. So again, showing that we're putting this technology into the industry, and it's being verified by governing bodies for use. So I think that's the first thing that that I want to say, is that the technology's really moved forward, and it's worth me just saying at this point that 3D printing may not always be the solution. I'm not saying 3D printing can do absolutely everything. There are different technologies that suit different parts, and different technologies are at different stages of development and suitability for industrial use and being certified. And again, there's applications that I don't particularly work in because Markforged suits a certain point, and you may not look to 3D printing for everything. But in my opinion, it's certainly a tool that you can and should turn to if the right application is there. So the second thing for me, and I think one of the big reasons why it's become more feasible or accessible, is the access to 3D printing and other services that you need to do this. So when we think about collective car restoration, as Dwight said at the start, focusing on one of the big problems is getting hold of legacy parts that are no longer produced by the OEM, and other manufacturing techniques for low volumes can be very cost prohibitive for that. So when we 3D print, we go from the part, we may have the part, we may have drawings of the part, we may have a broken part that we can try and reverse engineer, and this is a very simple stepped process, but we need to go from that part into CAD. We need to create a 3D model of it to then 3D print it. And if you don't know about, if you're not a CAD engineer or an engineer, or you don't know about 3D printing, of course that would be a very daunting task, or near on impossible. But there are now lots of services and platforms available to have access to this. So the first one to go from the part to CAD is design services, very similar to what Dwight offers, and huge amounts of businesses around the world now specifically focused on and experts in reverse engineering, 3D scanning, designing for additive. At the end of the day, additive and 3D printing is a manufacturing process, and you need to design for that and understand what technologies will suit that part that you're doing. And people who don't understand 3D printing or 3D scanning, have access to these expertise that can take their part, design it, give them advice. And the next thing then is, to actually print the part, and once you've got that, again, there's a huge amount of this platform available to you. We have 3D printing bureaus all across the world that print parts for you, and of course offer the expertise to design that part, which technology suits correct for that part that you're printing. And a huge amount of these businesses also offer this as a full service. So I've put in the diagram there that design services and printing bureau services are separate, and sometimes they are, but in a lot of cases they're all under one roof. So you as a business or as a classic car owner, can easily have access to these, and I think this is what really gets it to that point of being more feasible, is having access to this platform, which has come from various reasons. Again, 3D printing technology getting to the point where it is more cost effective for businesses to own, run and offer bureau services, but also with 3D printing being around for longer than my lifetime even, there are people out there with huge amounts of expertise in this industry, who you can gain access to and use as a service. So just on this point, a couple of examples. We thought a couple of examples of what's been doing here. So I'm going to fire back to Dwight, and he's going to talk about some of the things he's been up to.
Okay, thanks. Yeah, no, it's very interesting, and as you're saying, very feasible. And with 3D printing, what you touched on there is 3D printing. You can't just throw a picture into a machine and it produces a part. It does need the whole package of the 3D scanning, CAD, and then printing the material. What we've done here is a couple of examples here, which I just wanted to touch on. The replica wheel cap there, probably before December, we had a customer show up. He had bought a second-hand Land Rover, little small Land Rover, which he really liked, and it didn't have some of the wheel caps, and he couldn't find them on the market. So he said, could I just reverse engineer those and remake them for them? So we did. So those, but then also the one big thing, which is an ongoing project with us, is the speedo drive with the gear. We're working with closely with the Ford Anglia Classic Car Club to develop an alternative solution to a big problem that they have, because one of Ford, I think Ford made about 15 different variations of the speedo drive gear, and the club seems to be getting from on a regular basis requests for replacement gears. That gear was originally made with a nylon gear on a steel shaft, but obviously the shaft keeps coming off the gear, which is quite a big problem. So we're working closely with the Ford Anglia Club's gear company, or the gearbox company that does all the Ford Anglia classic cars, to develop or to do some R&D on coming up with a feasible alternative to the with the nylon gear on the detachable shaft. So we've sent them recently a shaft made completely out of nylon, so that as a single unit, the gear and the shaft made out of nylon. They're testing that at the moment, one with that and PETG and one in ASA plastic, all a continuous item. Now, to manufacture these as two separate parts, you're looking at approximately, in the traditional way, probably about 150 to 200 pounds for that shaft, because the shafts would have, the gears would have to be injection molded. You have to make the molding tool, which we all know making molding tool can cost about £3,500 to £4,000, and then you have to buy a minimum of £1,000. With 3D printing, what we've done is been able to redraw I've got 5 different variations of the gear, and then the shaft, which can just plug into any one of those gears. So I'm also comfortable to know that a gearbox generally sits at around about 70 to 80 degrees Celsius. Nylon, producing that in a 3D printed nylon, the nylon deflects heat up to about between 140 to 200 degrees Celsius. So I'm pretty confident that gear will maintain in the heat. Nylon also is very resistant to the types of chemicals you would find in a gearbox. Or the gearbox oils. So I'm confident that the gear will manage and sustain this. We just need to make sure that, and our gearbox guys at the Ford Anglia Classic Car Club, they just want to ascertain that it is, and they want to just in their mind make it clear. But we don't only do classic cars, as you can see there. We support all the use of all historic vehicles. So we will do boats, buses, trucks, all kinds of stuff. As that indicator lens there for the bus, that bus lens is actually for the Routemaster buses up in London. They have a problem where the indicator lenses keep cracking and keep getting broken. So we've had to redesign that, redraw that in CAD, and then get that certified by the DVLA to be used on their buses. There's, like I said, a variety of different other projects that we have ongoing. The fuel pump section, that there's for a three-wheel club. So it's pre-war club. They needed a fuel pump section made. To remake that in the traditional manufacturing method would cost too much, but producing that in 3D printed materials is far cost effective for them, because a lot of the times with the classic cars, it's small batches, not massive production runs. So that is what we do, and that is what we've been doing, and how we've been supporting a lot of the classic car clubs around the UK at this time. So I'll hand over back to you to carry on talking about the Markforged products.
Yeah, thanks, Dwight. So just going to give a brief introduction to the Markforged technology and what we're doing in 3D printing, and then I've just got a few case studies to share in this industry to show both 3D printing metal end-use parts, using 3D printing as a way of restoring cars for tooling, and then also the composite technology as well, which is offering a lot of benefits in reproducing, say, interiors where you don't necessarily need the strength. So Markforged was founded in 2013. Since then, they've brought to market a few different printers and technologies. Two main areas is composite printing, so plastic and using reinforced fibers, which we'll look at in a moment. Recently, in the last few years, they've become a worldwide leader for industrial 3D printing and metal 3D printing. Really increased and launched additive manufacturing software as well. So looking at actually AI software to improve the quality and accuracy of 3D print. So really just taking industrial 3D printing to the next level. And recently they've actually shown that they want to float on the New York Stock Exchange. So we should see huge amounts of growth and new technologies coming from Markforged over the next few years. When we look at where Markforged is used today, the additive, well, you can see on the right that a huge amount of our work is in the manufacturing space, but also automotive as well. Historically, we've done a lot with tooling, fixtures, prototyping. That's really been where we sit, certainly with our composite technology, but more recently we've seen a huge amount of use in end-use parts, both in the metal, but actually huge amounts in the composite side of the portfolio as well. Just briefly on the printers that we have at the moment. Again, I won't go into this in too much detail because we really want to talk about what we're doing, but just to set the scene for our case studies. Again, we offer two types of technology. The first is composite. So this is a nylon-based material, which we'll talk about in a moment. And we have a variety of printers that work with that technology. And then we also have this metal system as well for producing metal parts in various different materials. Our composite material, and really why Markforged came to market, was to bridge the gap between plastic and metal printing, okay, and find a cost-effective technology that can then offer the strength of metal, because at that time and even now, metal 3D printing is high cost, compared to plastic printing. But of course, the strengths of the material are much higher. Okay? So what we do is we print in a base material called onyx, which is a nylon base material with chopped carbon fiber. So we can see on the left here, it's about 1.4 times stiffer than ABS. So gives a hugely strong plastic part essentially in its own right. And we then add in reinforcement fibers to that, so Kevlar, HSHD and carbon fiber, which allow us to produce plastic or composite parts on much cheaper technology, much cheaper material costs that are very close to the strength of aluminium. And this really helped us replace historically metal parts with composite. But what we see at the minute in the classic car industry with this onyx material is it's a great material for printing interiors, again, where you don't necessarily need the strength. You can cover it in leather or paints, and print one-offs very cost effectively. With our metal system, we're printing in lots of different materials. Stainless steel would be probably the most relevant in this space, but also a few tool steels, and Inconel, and recently copper. Metal is a staged process, so you print the part in the metal powder, you then put it through a wash system, and then finally sinter it. Okay, so this actually bonds, heat treats the part to the final part dimensions and the strength of the material that you get. With plastic printing or composite printing, you're printing in layers, and very briefly, what this does is create a weaker direction where the layers can possibly rip apart or delaminate, as we call it. With metal printing, both in our technology and other technologies, because you are fusing or sintering the metal, you're actually getting very close to more like a cast material in terms of strength in all directions. And this is really where we're able to use metal for end use parts, because we can produce material parts and materials that have the strength of their cast counterparts. So just a very brief overview. As I said, we're really here to talk about using this in the classic car, but just to set the scene for some of the stories that I'm going to talk about here. So really, we just offer an industrial 3D printing platform between the hardware, materials, and software. So I have three stories I just wanted to talk through, which again show this technology being used for different things in different ways. So the first one is this RPG Industries story. I've just got a little video here which will hopefully play. I might just need to share the sound actually. Yeah, if I just share the sound there. If we can hear that.
My name is Bob Ginsberg, and I'm the president.
Yeah, you can hear that.
We are a job shop specializing in precision manufactured components. At RPG, we've always tried to be on the leading edge of technology. It started with wire EDM, and we added our first abrasive water jet machine in the late 1990s. We were one of the first shops in the area to have abrasive water jet. We've always tried to lead the market rather than lag behind. And we felt that additive was our next step. When we were introduced to the Metal X, we were blown away. We saw the possibilities. We can cut delivery times down considerably. We were able to print overnight, lights out, without any human intervention other than getting the printer started. We greatly save time, and time is money. We have a customer, D&D Automobile Restoration. They had a part from a classic car that they're restoring that is no longer available.
The part they're making for us now is for a Solex carburetor. It's a part we cannot find anywhere in the world at the present time.
This is a one-of-a-kind part, the perfect use for the Metal X.
We were desperate, and they approached us about this new technology that they had just acquired.
They were excited. They were getting very frustrated. We took the part from them, we scanned it, we created a model.
RPG printed a part in Onyx for us as a trial run. We fit that to the carburetor, and it fits perfectly.
They were able to tap the holes in the Onyx, test fit it, make sure that everything would work, and then we went ahead and committed to printing it on the Metal X. If you were to try to machine this part from scratch, it would be cost prohibitive.
It enables us to put this car back the way it was originally delivered, which we were unable to do at this point because we didn't have that part. Now we're going to be able to create that part and make this car whole. It's wonderful.
Composite and metal printing are really going to be the future in our industry, and we want to be the early adopters and the experts in that area before it becomes mainstream.
Okay, so that's just one example of, what we're doing in this space at the minute. I think I could talk all day, and experts in other metal print technologies, could talk about these stories all day. Really, there's a huge amount of examples out there of people doing this. But what I personally actually really like about this story is it shows that platform that's now available. It was a company who was specialised in this technology. It was, a classic car restorer who could well have been an end user, an end owner, who just needed this part. And it was going through that process. They reverse engineered it. They tested it using cheaper technologies, quicker technologies, which is the composite or plastic printing, and then finally printed it in metal and put it in the car and put it back on the road. And it just shows that loop that's now available, and really one of the big reasons why I think it's more feasible. Just a couple of other stories I wanted to share. This story isn't actually, this company isn't classic car restoration. It's a motorsport company over in Australia, Gary Rogers Motorsport. But I just wanted to share it because it highlights and talks about the fact that you don't necessarily always need to use additive for the end use part, and it doesn't always necessarily give benefit to the end use part. It can also be used to make other manufacturing techniques at low volumes more viable, and cost effective at this point. So they're actually 3D printing breaked up patterns, which they're using to lay up carbon fiber. So again, you're not going to see a lot of carbon fiber in historic parts, but the same idea, works for not casting every material, of course, but casting things like rubber and low temperature plastics, and other perhaps specialist tools or fixtures that you may need to support in the restoration process. And historically they were having these CNC machines, which was very expensive and a long lead time, and it made, it got to the point where they were just not making design changes that would have helped because of the lead times. And now using printing, they're printing it a lot cheaper and a lot quicker. But I think in the classic car world, in the classic car industry, this using printing for creating these perhaps tools or supporting hardware that you may never have thought of doing because it just never would have been viable, and never would have been cost effective to do that. So the last one I just want to share before I hand back to Dwight and sort of finish my part of this is composite printing, and again, I know we were sort of talking about metal printing initially, but we're seeing a huge amount of customers using plastic or composite prints for car interiors. This is a customer of mine actually that prints vintage Porsche parts, gear knobs specifically, but also handles, dashboard components, anything that's required really. Of course, you may not want this material on show because it's not in line with the original. But he's built his business over the last 20, 25 years since you were able to buy the parts directly from Porsche when they stopped making them, on buying the base metal part that was the interior of the gear knob, which they then covered in leather and put in the car. When they stopped making the cars and discontinued them, you were able to buy these parts or the surplus that they had directly, and he would then add the leather to them, make them look exact as the vintage. And over the last few years, that stocks of course have just run out. They're not making any more. Of course not. The stocks ran out. It was very hard to get hold of, so we needed to look for an alternative to continue to offer this service to customers. And again, I think this is a perfect example of it becoming more feasible. 15, 20 years ago, it probably wouldn't have been viable for a small business such as his to invest in additive manufacturing and use this because printers were more expensive, materials were more expensive. They weren't necessarily as accurate or as good quality. Now he's able to invest in one of our desktop printers, print these parts and use them. Once you've covered them in leather, or you can plate, paint, whatever it might be, it looks exactly the same as the original.
That's good.
So, that's it from me. Thanks everyone for listening.
Seamus, I'm just conscious of the time at the moment. So if you could just jump to slide 26, that'll be good. Because what we want to just talk of, because obviously with being able to look at the parts that are made and the parts that are produced and the technology and the materials, it's just good just to have a look at some of the technical data. Because as we know, when we're looking at traditional manufacturing, we also want to be able to see what is the technical data. How do they hold up to the original or traditionally manufactured materials? So if you could go to slide 26, we can just jump straight into the materials and the technical data on the materials, which is quite good. So one of the parts that is I'm often asked about or asked to use in remanufacturing spare parts is margin steel. So margin steel is if we know materials, margin steel is used in a lot of places where there is a high weight to stress ratio. So in other words, where there's a lot of pressure, a lot of weight, or a lot of stress placed on a particular item. And this type of material, margin steel, is normally used in the aerospace industry. It'll be used in helicopter undercarriages, in slat tracks, in rocket motor cases. And as we can see here in the list here, you got in dies and in pistons, in the conrods, in springs, in cannon recoil springs. So what I just wanted to highlight here, which is the main part, is when we have a classic car part remanufactured or reproduced in using 3D technology, using margin steel. Now, here the HRC is your key, your main part here is the hardness of that material. Obviously, the rest is also very important, the elongation at break, because and then you can see the elongation at break it changes when it's heated. So you've got, but the main thing is the HRC. So when it comes off the machine before it's sensed, you're looking at 33 to 37. But when it is after being heat treated or sensed, you're looking at 50 to 54 on the HRC. Now that grading, the traditional grading for Marked steel, the 50 HRC is a grade 255. The 54 HRC is a grade 300. So it's meeting the traditional hardness standard once it's been heat treated, which is the normal natural process of once an item as we heard, as that comes off the 3D printing machines, your hardness is sensed in a sensing machine, which is the average way. So if we can go on to the next slide for the stainless steel, we can move on to the next slide. Seamus, are you there? There we go. Thank you. So this is 17-4 pH stainless steel. Again, another type of material that I'm often requested to printing. I've put over there, you've got your composition of the material. So it is the traditional, the normal standard composition of material, copper, chrome, nickel, silicone, magnesium, and so on and so forth. And again, like I said, the main point when manufacturing parts to make it a usable part is the hardness of it. And I just want to point out there on once this has been hardened or sensed, using the H900 standard, you get a hard HRC at 36, which is on the bottom level of the standard. We think, well, where's stainless steel fun? I mean, I know. Sorry, one other thing I would like to just point out: stainless 17-4 pH stainless steel can also be pushed to its absolute limit, giving it a HRC of 44. That's pushing it to its limit when you are pushing it through the hardness testing or the hardness process using the H900 standard. Now we think, well, okay, this type of stainless steel, how strong, how durable is it? Where is it used? Obviously, stainless steel is used in food processing, turbine blades, in the nuclear industry, in marine, because obviously with marine, when you come looking to remanufacture parts in the marine, this stainless steel, 17-4 pH stainless steel, is very resistant to corrosion, which is the best, the good point on that. So if we want to look at the next slide, please, Seamus. We look H13 tool steel. So H13 tool steel, again, we're looking at a HRC after it's sensed at 45. When it's wrought, a further hardening, you're looking at an HRC of 46. So it is good. Well, this is normally used for stuff where it will be like a hot gripper dies, hot heated dies, aluminium dies, casting. So these will be used a lot for tooling, but then obviously not exclusively for tooling, but it's the better material when looking for some kind of specialized tooling, which again, 3D printing is a not only used for, or is not only a good add-on in the manufacturing process for making end parts, but making those specialized tools that are often needed when restoring older cars, even restoring modern cars. So that's pretty much where we got with our presentation. I am conscious of the time, so I wanted to just give 10 minutes. If anybody has any questions for either one of us, that would be great. We can you can unmute yourself or put a flag up. I see is that George has got his hand up. George's got his hand up already. So if there's a few more people who have questions, who would want to ask, you just unmute yourself and raise your hand and just talk. Okay, so George, let's hear what you have to say. Do you have a question there? We can't hear you. Hey, Giorgio, we can't hear you.
Is extremely interesting.
Can
you hear me?
Yeah, I can just hear you now.
Is maybe bad. Do you hear me?
Yeah.
Okay, I try again. Otherwise, I break.
Okay, no, you're frozen now. Well, if there's any other...
You cannot hear me. It's a problem. I don't want to make you lose time. I write the questions.
No worries, no worries. Does anyone else have a question? Anyone else got anything? Is there anything else you'd like to add, Seamus?
No, just thanks for your time today. It's
But now, one thing, Seamus.
LinkedIn.
Okay, if anybody wanted to contact you, and learn more about your products and all that kind of stuff, and the technology that Markforged has to offer, how can they contact you?
Yes, they contact us. We have a group email, printstronger@mark3d.co.uk. You can all find me on LinkedIn. Feel free to reach out to me on LinkedIn as well. Our website, mark3d.co.uk. And of course, Markforged is markforged.com. Reach out to them. They'll put you in touch with. If you're not in the UK, they'll put you in touch with someone local. We know we have a lot of contacts across Europe, so I can of course put people in touch with local resources as well.
Brilliant, thank you very much. Again, if to contact us, our it's Mitchell and Son 3D printing services. Our website is Mitchell Son, so MITCHELLSSON.co.uk. You can give me a call on 07878. Sorry, I'll write 0787 6131 539. And reach out to us if there's any parts that you need remaking, or if you want us to do any reverse engineering from. And like I said, we cover a range of industries. Our main focus is the classic car, but we also do a lot of work for architects, for B2C customers. So we've got a lot of customers who will ask us for bespoke items. We do a lot of work. We've done some work for the military. We've done some work for BAE Systems down in Portsmouth. So we will do reverse engineer or make parts in composite plastics or in 3D printed metal. So thank you very much for your time. I do appreciate it, and we do hope that to hear from you guys. And you can reach out to us. I'm on LinkedIn, Facebook, Twitter, Instagram. You can reach out and have a chat if you need to have a chat. So I am conscious of the time, and thank you that most of you have spent the last hour with us, and we appreciate that. But thank you very much, and we'll bid you a farewell. So have a good day. Bye.
Take care.
Okay. Goodbye.